Welcome to EduCasts, home of EduCasters. Situating the learning, the sociology of the classroom. Now that we have the methods down, we have to talk about the environment. You can't do cognitive apprenticeship in a vacuum. The context matters. This brings us to the concept of situated learning. A theory argues that knowledge is inextricably linked to the context in which it is learned. If you learn vocabulary words from a flashcard list, that knowledge is tied to the context of taking a quiz. It often doesn't transfer to writing a letter. Cognitive apprenticeship strives to create a culture of expert practice. The classroom shouldn't feel like a holding cell. It should feel like a workplace. Authentic tasks. To make this work, the tasks have to matter. Authentic doesn't necessarily mean fun. It means the task is similar to what people actually do in the real world with that knowledge. If we are learning history, an authentic task isn't memorizing dates for a multiple-choice test. Historians don't do that. Historians look at conflicting primary sources and try to construct a narrative of what happened. So an authentic task would be giving students 2 diary entries from the Civil War that disagree with each other, and asking them, who was telling the truth? How do you know? When students engage in authentic tasks, the motivation shifts. They aren't working for a grade. They are working to solve the puzzle. They begin to see the value of the skills because they need those skills to accomplish the goal. Intrinsic versus extrinsic motivation. Traditional schooling runs on extrinsic motivation, grades, gold stars, avoiding detention. Apprenticeship runs on intrinsic motivation, the desire to master the craft. The apprentice wants to learn to shoe the horse because they want to be a blacksmith, not because the master is going to give them a B+. In the classroom, we foster this by showing students the power of the skills we are teaching. We show them that math helps you understand the world, that writing helps you persuade people and get what you want, that science helps you fix things that are broken. When students see the utility of the knowledge, they buy in. They stop asking, is this for a grade? And start asking, how do I do this better? Real-world applications. What this looks like. Let's get out of the theory and step into some classrooms. What does this actually look like on a Tuesday morning? In the math classroom, imagine a teacher introducing long division. Traditional, writes the steps on the board, kids copy. Kids do 20 problems. Cognitive apprenticeship. The teacher puts a really hard division problem on the board, one that they might actually struggle with. They start solving it aloud. Okay, 15 goes into 400. Well, 15 times 2 is 30, so that fits. 15 times 3 is 45. Nope, too big, so it has to be 2. Let me write the 2 up here. Now, where do I put the 30? Oh, right, under the 40. They intentionally make a mistake. Wait, 40 minus 30 is 10. Bring down the 0. Wait, did I copy that number right? Let me check. They model the checking mechanism. Then they give the kids a problem. The teacher walks around, coaching. I see you put the 3 there. Talk to me about why you did that. Articulation. Later, the teacher gives a word problem about splitting a bill at a restaurant. Situated learning, authentic task. In the writing classroom, traditional, write a 5-paragraph essay about Romeo and Juliet. Cognitive apprenticeship. The teacher projects their laptop screen. Okay, class, I have to write a letter to the principal asking for funding for our field trip. I'm nervous because he usually says no. Watch me draft this. The students watch the cursor blink. They watch the teacher type a sentence, delete it, and type it again. I started with, we want money. But that sounds too demanding. I need to sound professional. Let me try, we are requesting financial assistance. Modeling. The teacher asks the class, what do you guys think? Is that too formal? Coaching reflection. The students see that writing is rewriting. It destroys the myth that good writers just vomit perfect prose onto the page on the first try. In a science classroom, traditional, a cookie-cutter lab where the result is already known. Mix A and B to get C. Cognitive apprenticeship. The teacher presents a mystery. The fish in the class tank are acting weird. Why? The teacher models the scientific method not as a list of steps, but as a way of thinking. Well, what changed? Did we change the food? The temperature? Let's test the water. The students have to hypothesize. Articulation. They run tests. Exploration. They compare their data with other groups. Reflection. They are being scientists, not just science students. A challenge is, why isn't everyone doing this? If this sounds amazing, you might be asking, why isn't every school doing this? The honest answer, it's hard. It is really, really hard. Time constraints cognitive apprenticeship is slow. It takes time to model thinking. It takes time to let students struggle and coach them through it. It is much faster to just lecture and give a multiple-choice test. In an American education system that is obsessed with pacing guides and covering a mile-wide, inch-deep curriculum, teachers often feel they don't have the luxury of time. Class-size apprenticeship traditionally works with a ratio of 1 master to maybe 3 or 4 apprentices. An American public school teacher has a ratio of 1 to 30 or more. Coaching 30 individual students during a 50-minute period is a logistical nightmare. It requires the teacher to be incredibly efficient and to use peer coaching strategies effectively. Standardized testing. Our testing system is built on inert knowledge. It tests recall and basic application. It rarely tests deep, process-oriented thinking. Teachers are under immense pressure to get test scores up, which encourages teaching to the test, the exact opposite of cognitive apprenticeship. It's a brave teacher who says, I'm going to ignore the test prep drills and teach my kids how to think, trusting that the scores will follow. Spoiler. The scores usually do follow, but it takes guts to take that leap. The expert blind spot. Finally, there is the challenge of the teachers themselves. Many teachers are experts in their content. They have been doing math or reading history for so long that they have forgotten what it feels like to struggle. Their knowledge has become automatic. To teach using cognitive apprenticeship, a teacher has to decompile their knowledge. They have to slow down and remember what the individual steps are. This is surprisingly difficult. It's like asking a pro golfer to explain exactly what their left pinky toe is doing during a swing. They probably don't know anymore. They just do it. Teachers need training to learn how to unpack their own expertise. Despite the challenges, cognitive apprenticeship remains one of the most powerful tools in our arsenal. In a world where information is free, where any kid can Google a date or a formula in 3 seconds, the value of education is no longer in the transmission of facts. The value is in the transmission of wisdom. We don't need students who can recite the steps of the scientific method. We need students who can think like scientists when they read a news article about climate change. We don't need students who can diagram a sentence. We need students who can craft a persuasive email to their boss. Cognitive apprenticeship bridges the gap between the abstract world of school and the concrete world of life. It respects the student enough to let them in on the secret, that being smart isn't magic. It's a process. It's a set of strategies, habits, and ways of seeing the world that can be learned, practiced, and mastered. When we fill our classrooms with the sounds of thinking, teachers modeling their confusion, students articulating their logic, peers coaching peers, we are doing something ancient and radical at the same time. We are rebuilding the village workshop in the modern school. We are telling our students, I'm not just going to tell you the answer. I'm going to hand you the hammer, show you how to hold it, and stand right here while you take a swing. And that, ultimately, is what education should be. Not a transaction of data, but a transformation of the self. It's about passing the torch from one generation of thinkers to the next, ensuring that the flame doesn't just survive, but burns a little brighter.